All right, so I ran out of time, so this is part two. But what I was saying is that when we're simplifying something that's written in this form here, this is not simplified because we have bases that can still be combined together. Excuse me. Now this one is a little bit different. So you're going to see that we have this term here, and we're going to have this term here. And when we have two terms next to each other without any kind of symbol, addition, subtraction, multiplication, division, this means that this is multiplying together. So this one is also being multiplied together. When we have a multiplication problem, it does not matter what order we do the multiplication in because it's going to be the same outcome no matter how you order it. Now, say you had 4 minus 3, that would equal 1. We could not change the order of this because 3 minus 4 would be negative 1. So that's why, problems like subtraction and division problems, they can have to stay in the same order. They cannot be manipulated. Multiplication and addition problems can. So what we're going to do, let me get rid of this. Still getting used to this. Excuse me. We're going to reorder these so that the like bases are together. So we have this base here. We have a negative 3, so that's a base. We have an x squared, so I'm going to move that over here. That's one other base. Now we have this 4, so I'm going to take that over here. And we have this x to the 5th. I'm going to take that over here. Now the reason why I used this order is because these two bases are numbers. They can be combined together. So if we looked at this as a multiplication problem, we could see we can take negative 3 and we can combine it with 4. So a negative times a positive is going to be negative. And then 3 times 4 is going to be 12. And it's still being multiplied by these terms here. With our law, it says if they have the same base, then we can add the exponents. So we would take 2 plus 5, and we'd have 7. So we'd have x to the 7th. And if you have it written like this, I would accept this because it is being multiplied together. But if we simplified it, we could really actually just write it like this because it's understood that there's multiplication there. So this one over here is going to work the same way. It just looks a little bit different because now I have the parenthesis. This still means that I'm multiplying this by this term. So we can rewrite it. So negative 2m times negative 8m to the 6th. And we would do the exact same thing. So it would be negative 2 times negative 8 times m to the 6th. So now we can just combine these two together. They're both numbers, so we can perform this operation. So a negative times a negative becomes positive, and then 2 times 8 becomes 16. So we got a positive 16 there. This is a 1. Remember what I said, whenever we have a term without an exponent, that's understood that there's a 1 there. So 1 plus 6 is 7. So our final answer will be 16m to the 7th power. Again, if I went too fast, make sure that you stop, pause, rewind, anything that you need to do so that you can go back and follow along with the notes. All right, that's it.